All right, so here is objective for today is to take this stuff that we've been working on and make it a lot easier, okay? Because we can do in about 5 minutes here all of those problems that we just talked about, that 1 through 10, you probably could have done those in less than 5 minutes. The whole worksheet. Seriously. Okay? There are some shortcuts. We're going to talk about the shortcuts today. Because you don't want to have to go through that same process. If there's an easier way, you don't want to have to go through the longer version every single time that process. Okay? So we are going to use what's called the power rule. It's probably the number one rule that you want to use when dealing with derivatives. Okay, we'll get to that. And then sum and difference rule is very basic. It's not that big of a deal. To find derivatives, and then ultimately the one extra thing we're going to add in today is writing an equation of a tangent line. Okay? So concept-wise, real quickly, I asked you yesterday, you don't have to write this down, but I asked you 2 days ago, what is a derivative? What are we finding when we find the derivative? Slope, right? Specifically, we said as you work your way through curves, it's the slope at any specific point on a curve. Here's what that looks like. I wanted you to be able to visualize this. There's what this is actually looking like. If here's some random parabola, and you notice, I'm going to switch here to right here at this point, you might be able to see there's kind of a pink, there's a tangent line right there. Tangent meaning it just barely touches. Not tangent like sine, cosine tangent. When two things are tangent to each other, they just barely touch. Today we're going to talk about the equation of a tangent line. Here's a tangent line right there. When I say what's the slope right here at this point, it's the slope of that line tangent. When we get up here to the vertex, there's a slope of that line right there. Okay? That's what you're actually finding as you're working your way through those different derivatives. You're finding the slope of the line that's tangent at that point. Okay? If I give you a couple of other ones, here's some other graphs just to kind of see what we're looking at. Notice again at point P here, this one kind of looks like it might be a cubic type function. There's the slope at that point. Here's your tangent line at that point. This is what we are actually finding. This is what we're doing when we're finding a derivative. Okay? So, real quickly, with that concept being said, I don't even know what I'm trying to say today. With that being said, the derivative of a constant, okay, is very, very straightforward if we keep that in mind. If the derivative of a function is its slope, think about a constant function, y equals 3. Okay? What's the slope of y equals 3?
3. 0.
Horizontal line has 0 for a slope, right? There's no rise. Doesn't increase, doesn't decrease. Slope of a horizontal line is 0. What if I said my constant was -2? What's the slope of line y equals -2?
0.
0. What's the slope of a constant, or what's the derivative of a constant?
0.
0. Anytime you take the derivative of 5, -2. Anytime you're taking the derivative of a constant, the derivative of a constant is 0. And that's because every constant is really just a horizontal line, so therefore has a slope of 0. This part that's right here in the middle, this is just kind of notation-wise. C being the constant, okay, whatever number that might be. The derivative of a constant is always equal to 0. All right. Like I said, we're going to use that as part of our process. So here's the worksheet we just went over. Here's the assignment from the definition of derivatives that we just talked about. Here's what I want you to take a look at. Okay? I don't have the answers, like I don't have them memorized, I haven't looked at them, okay? Here's what I'm going to tell you. As I work my way through this sheet, the first derivative, is 2x. This one, we actually did this one, but this derivative is 6x minus 2. Number 3, the derivative is 6x. Number 4, the derivative is 8x minus 2.
You gotta be kidding me. The next one.
Tell me what I'm doing.
Take the coefficient times the exponent.
If you take the exponent and you multiply it by the coefficient that's out front, and then what do you do with the exponent?
Drop it a degree.
Drop it a degree. You just found the derivative. That's called the power rule. Told you, you could have had this whole worksheet done in 2 minutes. Okay? Number 5, yeah, this one's 6x squared. That's that derivative. Quick question, by the way, because this will come into play as well. What about this one? This one is a little bit more difficult. What about number 6?
0.
Nope.
It's a fraction. You put it all close square or power.
1.
No, it's still the same. How do I rewrite that so it looks like this? Negative 1 power. This is really x to the negative first power. And now you do the same thing.
So
Which means if you took the derivative of that,
it's negative 1.
negative 1 comes out front, times the one that's already there, you get negative 1 x to the, what?
0.
Nope. Goes down 1. Okay, remember it always goes down 1 to the negative second, which if I then rewrote that, isn't that just negative 1 over x squared?
I don't know.
Which also happens to be the derivative that's on your sheet. Okay? What's the derivative of number 7?
12x.
12x squared.
God, yeah, so great.
What's the derivative of number 8?
4.
4x.
4x cubed. There's your derivative. What's your derivative of number 9?
2x.
2x what? Plus 1. 2x from the x squared, plus 1 coming from the x.
If it's
Okay.
not an x in the next term, like let's say like plus 2. Is it
Hold
just
that
a
thought,
y?
because the next one is. What's the derivative of the next one? 1 second, Lindsay. Negative 1. Yep. Which we did, right? And the reason is, we just said derivative of a constant is 0. So the derivative of 3 is 0. So we're really just focused on negative x and doing it the same thing. Yeah, Lindsay, question?
For number 9, it's 2x plus 1. Where does that plus 1 come from again?
So it's coming from right here. Okay, so if you take this power and you bring it out front and then you drop it, then it becomes x to the 0, which means the x's are gone. Okay, that's where that's coming from. See, we just did the whole sheet in like 30 seconds. Told you might be mad at me for a short amount of time. That you spent 2 days doing it the long way, getting the concept of definition of a derivative, a lot of a different algebra. The good news is this. So we did talk about let me ask you this one. Let me ask you this one. What about the square root ones?
Those are
Yeah,
hard.
I did not like
that. I don't know what to do on them.
Any ideas on those? How could I apply what we're talking about on this with square roots?
Just get rid of it.
Nope. Because you could do it the long way, but obviously we want to try to do it a shorter way. We said this is a power rule. What's a square root is what power? 1/2. And then you could work on the square root problems as x to the 1/2 and do it that way with the power rule. Those are the types of things we're going to kind of start practicing as we work our way through the rest of this week and into next week. Okay, some of the different rules, and so that we don't have to get around and do it that way. So here's your actual definition. Here's what we're actually doing. Okay? Power rule is this. So we saw that if y equals x squared, then the derivative, y prime, was 2x. And here's your actual power rule. If n is a positive integer, that means the derivative of x to the nth power is really, you bring the n out front, times x to n minus 1 power. One less. Okay, that's exactly what we just did. To differentiate x to the n, you multiply by n and subtract 1 from the exponent. This is the number one rule that if you can get something so that you can use the power rule, if you can write something in terms of a power, this is the easiest way to go always. Okay? There's other rules we're going to talk about, but this is always the easiest one. If it's possible to write something in terms of a power, then you should do it. Okay? Like I said, even square roots, cubed roots, write them as the 1/3 power. Okay? It's a lot easier to do it that way than it is otherwise. When it says to differentiate, by the way, that just means taking a derivative. Finding the derivative is called differentiating. All right, how about these real quickly? We kind of did this already, but x to the 4th. What's the derivative? Okay, yeah, f prime would be 4x to the 3rd. There's your derivative. And if you then wanted to find the slope at any given point, you plug in whatever value of x, and you find your slope. Okay. Think about this one for a second, by the way. If I asked you to find y equals x to the 8th prior to 5 minutes ago, think about the amount of work you would have had to do.
Yep, that would suck.
X plus h times x plus h times x plus h times x. Multiply that all out. Which also, by the way, you remember back to Pascal's triangle and the binomial theorem and all that kind of stuff? Okay? That's where the binomial theorem would help if you remembered that stuff. But in this case, now that we know the power rule, y prime equals 8x to the 7th. And we just saved ourselves a whole lot of time to get to the same end result. Okay? One last question. This is kind of what you were asking me before, Olivia. What about something like this one? What about x squared plus 4? What's my derivative? 2x. And then basically you're taking the derivative of each part. Derivative of x squared is 2x. And the derivative of 4, a constant, is 0. Derivative of constants is always 0. So there's your derivative. Okay. Making some sense, hopefully? Getting the idea? We just did something as well, by the way, that talks about another rule. It's a very straightforward one. I'm going to give you the rule, though, just so you have it. They're called sum and difference rules, and here's all this is really saying. Here's your mathematical definition. Here's what this says. Before you don't need to write all this other stuff down. Right here, this is saying if you take the derivative where you're adding or subtracting terms, just take the derivative of each term one at a time. Okay? That's what the sum and difference, like we just did. When I said x squared plus 4, we did the x squared, then we did the plus 4. We used the sum rule on that one. Okay? That's all that this is saying is you can take the derivative of each term one at a time. You don't have to worry about it as a whole process. And like I said, you don't necessarily need all the top part. You just need to know that you take the derivative of each individual term and then put it all together at the end. All right. Let me give you, here's what I want you to do. I'll give you a couple of minutes here. I want you to practice. Let's see. Let's start there. Start with those 4. And you don't even necessarily, if you want to write them down, that's fine. Okay. Otherwise, if you want to just kind of start putting answers down and just putting the derivatives, just a practice, see what you can do. Tell me what the derivative of each one of those is. Be a little bit careful on number 4 when you're working with the negative exponents. But find your derivatives. I'll give you 2 minutes. Find your derivatives. See what you can actually do. You could, if you write it without negative exponents, yeah. I would start it like that, though. All right, let's see what you came up with. What's the derivative of the first one? 4x cubed, yep. Okay. That one's quick. Second one. 12x squared minus 4x plus 6. And then the derivative of the minus 8 is 0, so that part goes away. There's your next derivative. How about the next one? 1. Derivative of x becomes 1, okay, the one that's in front, the coefficient. And then the minus 4 has a derivative of 0. So that actually is 1. Let me move this up for a second. How about number 4? I told you to be careful on this one. Let me focus it down here quick. How about number 4? Bring the exponent out front. You get negative 12x to what power? Negative 4. Drop it 1, which means it's becoming more negative. So to the negative 4th power. Then we move plus 4 x to the negative 3rd power plus 6. Yep. And again, the minus 8 goes away. There's your derivative. Exponent times coefficient, and then drop the exponent by 1. Okay. Now, if you wanted to rewrite this, which we'll talk about, if I wanted to actually rewrite the derivative at this point, that x to the negative 4, remember that's just x to the 4th in the denominator. X to the negative 3rd is really just x cubed in the denominator, okay, anytime you have a negative exponent. What about something like this? No. Okay. General rule, again, there is a different rule. It's called the quotient rule. We'll get into that, okay? Matter of fact, we're going to get into that tomorrow. But I told you, number 1 rule is if you can go through and do things with the power rule, that's the rule you want to work with. So that's what we're going to do. Since all of this stuff is divided by 2x, let's just divide each part. Okay? Let's rewrite this so that it kind of looks like an actual polynomial. Meaning, if I take the x to the 4th and divide it by 2x, that x will cancel out one of those. Makes sense that that's really just 1/2 x cubed. Okay? You got a 1 right there. That's where the 1/2 is coming from. Then if I divide the next term, that x will cancel one of those out. You're left with negative 3/2 x squared. And then if we go to the last one, the x's cancel out. There's still a 1 sitting here. So you're left with plus 1/2. These two are the exact same thing. Now you could take the derivative using your power rule. If you bring your exponent out front, you end up with 3/2 x squared. When I multiply 2 times 1/2, we get minus 3x. And then the derivative of a constant, in this case it's 1/2. There's your actual derivative. That part goes away. Okay. So if you can change something into a polynomial where you can actually use powers, it's a lot easier than what you would have to do otherwise. And like I said, we'll talk about that other option. Because you can't always do this. I'm just saying if you can do it, you should. Okay? I'm not going to do the last one, but I want to ask you a question about the last one. What would I have to do on this one? How would I have to rewrite this one just to get going? What is it? I'm going to stay away from that.
So the negative 2.
Yeah. What I would do instead, you just got to focus on this part right here. Rewrite that as 3x to the negative 2nd. Just like number 4 that you were dealing with, and then take your derivative from there. Okay? So anytime you can rewrite something not as a fraction, that's why I was staying away from I don't want to necessarily write it as a fraction. I want to write it as a power. So this is really just 3x to the negative 2nd. And then you find your derivative just like number 4. Okay? There's your basic idea. Let me go one last example here. One last concept right here. So given this function, okay, 4 minus x squared, we've got a parabola that's opening down. I want to find the slope, and I'm going to actually write the equation of the tangent line at x equals 1. Okay, I want to actually write that equation. So in order to write equation of a line, you need two things. You need the slope, which we'll find in a second. That's where the derivative is going to come into play. We're going to use the derivative to find the slope. And then the second part is I need a point in order to either find my y-intercept or come up with the equation. Okay? So first off, notice I've got x equals 1. So that means I've got an x coordinate of 1. How do I find the y coordinate? Yeah, just plug it in. What do I get? 3. Yeah, 1 squared is 1. 4 minus 1. So there's the point right there that we're actually going to have. It's going to be the line that's going to be tangent. It's going to be tangent at that point. Okay, that's where it's going to touch the parabola. Well, I need to find the slope. In order to find the slope at that point, that's the whole concept of derivatives. That's what we said. If I can find the derivative, plug in x equals 1, it'll give me the slope. What is my derivative? What is f prime of x? Yeah. The 4, basically we ignore that because that constant becomes 0. So we're really just focused right here. So we end up with negative 2x is your derivative, which means what's the slope of the tangent line at x equals 1? Negative 2. If I now take 1 and I plug it in, it will give you the slope at that point. Okay? So slope of your tangent line, in this case, is negative 2. Okay. Just taking x equals 1 and plugging it in, giving you the slope. Okay? Now, the reason I have this part covered up, just a reminder, you got two different versions of equations of lines. I think most people are probably most comfortable with y equals mx plus b, okay, which is fine. In Algebra 2, you also learned about point-slope form. This is actually probably the easiest form to write this in, because you literally take the point and the slope and just plug it in and you're done, okay? But all of the answers that on the assignment that I'm going to give you today are all in y equals form. So I'm going to go straight to that. Which means I need two things. I need numbers for two things. I need a slope and I need a y-intercept. We have the slope. How do I find the b? That's why we needed the point. Yeah, we take the point, we plug it in, we take the slope. So let's do that real quickly and just finish this one off. So if we take the 3 and I plug it in for y, we've got 3 equal to, slope is negative 2, x coordinate we said was 1, and now we solve for b. This gives you negative 2. Add it over, we find out that your y-intercept is 5. And therefore, the equation of the tangent line is y equals negative 2x plus 5. Okay? That's the only additional part that we haven't talked about yet. Okay? So just like at the very beginning of this lesson, let me go back for a second, where we talked about all these different lines, what we just found is the equation of the line at x equals 1. Okay? We found the equation of that tangent line. Let me stop there for a second. Anybody have any questions? Otherwise, it's basically practicing your power rule and then being able to do like what we did on the last example here. Okay? So, derivatives worksheet number 2, which I'd say is a pretty good chance you're going to be able to finish this or come close to it in the 15 minutes of class that you have left. Okay?